Right. So, oh, that's where this was. Okay, so section 5.4. Like I said, a brand new set of identities in this one. We call these the sum and difference identities. Why are they the sum and difference identities? Because it's if you have sine of two angles, right? So not sine of 30 plus sine of 60, right? No, it's sine of 30 plus 50. Okay? So it's a sum of an angle. So here we have sine of A plus B, cosine of A plus B, and then the minuses, right? Oh, see, there's always, this should say minus here. Can you guys fix that? The cosine. Yeah, this should say minus, but everything else is right. Okay? Everything else is right. It's just that that is a minus. Okay. So, no. Everything else is right. Don't make up math. Just fix this one. The others, these are correct. So, let's take a look now. So you have sine of A plus B, right? Each one of them gets split. So you have sine of A, cosine of B, cosine of A, sine of B. So take a look. This is important. So you know how you have A, B, right? Here too you have A, B, A, B. That doesn't change, right? So A, B, A, B, A, B. That doesn't change. And so take a look. Sine of A plus B, sine of A minus B, right? These are the same. The only thing that's different is the plus or minus in between is switched. Okay? Cosine of A plus B, again, these are the same. The only thing that's different is the sign in between them is switched. So if you write them in this order, okay, you can actually, sing to it. So you guys know, like, Twinkle, Twinkle, Little Star, right? I think it's that tune. So it's literally the same thing, just with a tune. And I don't know if it makes it any easier, but it's sine, cosine, cosine, sine, cosine, cosine, sine, sine. And that's how we remember it, right? So sine, cosine, cosine, sine, cosine, cosine, sine, sine, right? But remember, it has to go with like sine and then cosine. Now, to write it in a very concise form, you can do this. So sine of A plus B is, look, sine, cosine, and then it's plus plus, cosine, sine, right? Sine, cosine, cosine, sine. Okay, that's how it goes. Now, to write it in more concise form, so you don't have to like repeat, if this is a minus, then this becomes a minus. You see that? That's how we write like the two of them in concise form. And then, so like for the cosine, do you see how for the cosine, if it's a plus here, then it changes to a minus, right? But then if this was a minus, it would be a plus here. Okay, now, another way that my students remember is sine, right? It alternates, sine, cosine, cosine, sine, but to compensate, the plus stays a plus. Cosine, it stays like cosine, cosine, sine, sine, but to compensate, the plus changes to a minus. I mean, however you want to remember that is up to you. Tangent, I don't have a song for that, but we never say this has been distributed, but you know, you have like tangent A plus tangent B. So plus plus, then it'll be one opposite sign, tangent A, tangent B. But still there is a pattern, right? Because it's tangent A, tangent B, same order, addition, multiplication, and then plus minus, and this is just opposite sign. Okay, enough of that. You do have to memorize these though. Okay, now, why do we use these? Well, we know how to find the trig functions of special angles on the unit circle, right? But the only angles we've been dealing with this whole time are the 0, 30, 60, 90, 45, right? Well, what about all the ones in between? What about sine of 75? We haven't even like acknowledged the existence of those angles. So we have to have a different way to evaluate those. Well, what you can do is you can write angles in terms of special angles on the triangle, on the unit circle. So for example, you can say, oh wait, sine of 75, I can write 75 as 30 plus 45, okay? And now this becomes sum identity, right? This is the sine of a sum of an angle. So what happens now is the 30 will be your A, and the 45 will be your B. Now, somebody's going to ask me, well, what if you wrote sine of 45 plus 30? Does it make a difference? Absolutely not, okay? So now we plug it into the formula. So it's going to be sine, cosine, cosine, sine, right? And the 30 and the 45 stay in the same order. So sine, cosine, plus plus, cosine, sine. Okay? Sine, cosine, cosine, sine, right? So during the pandemic, when I would teach this over Zoom, my little one, who is now in 4th grade, he was like in kindergarten, or he was like 5 at the time, he would sing it, but he didn't know where one word ended and the other one started. So he thought it was like sine co, because you don't know. It was like sine, cosine, cosine, sine. Like you don't know where one ends and one starts. So it was like a thing. He would just sing it all day long. Anyways, now, do I know what sine of 30 is? I do. It's a half. Do I know what cosine 45 is? 1 over root 2 plus cosine 30, sine of 45, right? And now, look at this. This is 1 over 2 root 2, root 3 over 2 root 2. Oh, look, they even have the same denominator. So it's 1 plus root 3 over 2 root 2. That's it, right? And whereas before, you would have never been able to figure out what sine of 75 is. Look at that. Now you can. Like, look at how impressive and like how cool that is, right? So look at how powerful this identity is. Okay, next, we have a sine of negative 7 pi over 12. First, let's address that negative, right? We don't want that negative in there. It's bothering me. Let's take it out. We know, however, that if you have sine of negative theta, what happens to the negative? It's negative sine theta. So I can rewrite this as negative sine 7 pi over 12. So this is going to be negative sine. Okay, so here is where you have to come up with two angles in radian that add to this. The way I do it, here's how I do it. You know how the denominator is 12? I just make two fractions with a denominator of 12, because sometimes you can figure it out, sometimes you just can't, okay? Now, I want to find two numbers that add to 7, but that when I put them over here, that over 12 will reduce to a special angle. For example, 1 and 6 does add to 7, but if I do 1 over 12, does that reduce to a special angle? No. 2 and 5, also the 5 doesn't, but 3 and 4 does. So 3 and 4. So now this will be negative sine, and then reduce it, pi over 4 plus pi over 3. Okay, so it's just a way to do that. Okay, now I got A and B again. Negative stays out here, and again, it's going to be sine, cosine, cosine, sine, right? So sine, cosine, plus cosine, sine. And the order of the angles will stay the same, pi over 4, pi over 3, okay? Now, I know what sine of pi over 4 is, 1 over root 2. What's cosine of pi over 3?
One half.
1/2. plus cosine of pi over 4 is 1 over root 2. Now, if cosine of pi over 3 was 1/2, sine of pi over 3 is going to be the other one, root 3 over 2. So this is going to be negative. Okay, look, they all have, like, it's 2 root 2, 2 root 2 again.
-1 plus root 3.
Right, negative 1 plus root 3 over 2 root 2. Now, that's one way of writing it. You could also distribute the negative, and it'll be negative 1 minus root 3 over 2 root 2. Or this is the same as a negative out here, 1 plus root 3 over 2 root 2, right? These are all the same. Or 1 plus root 3 over negative 2 root 2, right? This is like pre-algebra stuff, but all of these are the same, right? All of these are the same. But if you are taking a multiple choice test and you came up with the answer, but the answer was written in some other form, you should be able to recognize that they're all the same. Okay? Now, these identities, right, you can use them to go in this direction, right to left to right, or you can use them to go in the other direction, right to left. In fact, that's what we have over here. I have this complicated mess over here. Tangent something minus tangent something else, blah, blah, blah. But when I look closely, what is it that I have? I have tangent of A minus tangent of B, 1 plus tangent of A, tangent of B. Okay, is it just me, or is that not exactly this right here? The bottom one, right? So all that is equal to what? Tangent of A minus B. So I say, oh my gosh, this is equal to tangent of 78 minus 18. That's it. But, well, almost. What is 78 minus 18? 60, which is root 3. Okay? And what about this one? Now you see this and you're just like, oh my God, what the heck is this? But looking closely, you always don't want to freak out, okay? But you want to see a pattern. The way I would look at this is I would say, okay, I have cosine of an angle, cosine of another angle, plus sine of the same angle, sine of the same angle. Oh my God, this is a pattern. Cosine A, cosine B, sine A, sine B. This is cosine, cosine, sine, sine. So this is the same as cosine of, is it A minus or plus B? Minus, because remember the cosine switches the plus to minus. So, now, we do a little bit of common denominator, right? We're going to multiply this by 3, this by 3. 21 pi minus 5 pi, 16 pi over 24, which is cosine 2 pi over 3. Oh my God, and I totally know what cosine of 2 pi over 3 is. How much is it? A little bit over, a little bit over. Negative a half. Negative a half. Okay. So, okay, next one. Again, I take a look at this and it seems so complicated, but then what is it do I have? So it says, write each trig function as an algebraic expression of x that does not involve any trig functions. So I look at this and I'm like, okay, cosine of blah plus blah. Oh, that looks like cosine of A plus B. Well, I know exactly what that is. I have a formula for that. But first, why don't we simplify anything that can be simplified? So, what's this? Arc sine of root 3 over 2. Pi over 3. So, what is the angle for which the sine is root 3 over 2? Pi over 3. So I can just rewrite this as cosine pi over 3 plus arc cosine x. Now look, you can keep it as arc cosine x, or if you want to write it as inverse cosine, so it's like shorthand, you can do that. Okay? So now we're going to expand this. Never say distribute. Expand. This is a cosine, so it's going to be cosine, cosine, sine, sine. So cosine of the first, cosine of the second. Yeah, eventually, yep. Cosine, cosine, plus or minus? Minus sine of the first, sine of the second. Isn't this fun? So, cosine of pi over 3 is what? 1/2. Times, how much is this? X. Minus, okay, if cosine of pi over 3 was 1/2, sine is the other one, root 3 over 2. Not times x. Now this one, we have to do some work. Just this in 4.6 was a problem of its own. Now it's 1/4 of a problem, and this is math, right? Everything that you learn will now be a component in a much bigger problem.
Oh, I feel like the one.
So, yes, so I have an angle theta, the cosine of which is x over 1. We have to do this with a triangle.
Wait, why is
So it'd be
it
Okay, hang on. Hang on. Shh. Huh?
why is there cosine?
So remember how this was arc cosine? I wrote it. Okay, so here I do this. Now I need to find this. It's always going to be the square root of 1 minus x squared. Okay, that's from last chapter. Let's do like a bonus or afterwards. Just this that I've highlighted in red was from, okay, yep. So now I need the sine of this, so it's root 1 minus x squared over x. Oh, over 1, sorry. So now, okay, now, look. Okay, so now look. This has the first one has a denominator of 2. This has a denominator of 2. So this whole thing is going to have a denominator of 2. In the numerator, I have 1 times x, x, minus root 3 times this. You can combine them. So it'll be, okay, so it's root 3 times this. So this will be x minus in 1 square root 3 times 1 minus x squared over 2. Now, people will try to factor this 1 minus x, 1 plus x. No need, because it's not going to help you like further progress into the problem. People want to distribute the 3. No need. It's not going to help you progress any further in solving this problem. This is it. It's good. We're done. Nice and clean. Okay, so, okay. Now, similar problem here. I have sine of a minus b. Arc tan of x, I can't do much about, but arc cosine of 1/2 is how much? Pi over 3. But I can write this as like inverse tangent. Okay, writing this as inverse tangent, it's choice. I'm only doing it because it's literally like less ink. That's it. Okay, so now this is going to be sine, cosine, cosine, sine. Okay, so this is now sine of, you don't have to write it over again, but I'm just going to, so people can see what I'm doing, okay? So this last thing that I wrote is optional. Okay, now, this is going to be sine, cosine, plus or minus, minus, cosine, sine. Okay, so Here I have inverse tangent of x. Why don't we draw that triangle? This is theta. Yeah. Okay, so the tangent of this is x over 1. Opposite over adjacent is x over 1. We're missing a hypotenuse. Because that's the larger side, it's going to be the square root of what? X squared plus 1, or 1 plus x squared. Okay, now, the sign of that situation is how much?
X over X squared.
Correct. Okay, times, what's cosine of pi over 3?
1/2.
Minus the cosine of that. Look, it's the same angle, right? The cosine is what?
1 over X.
Right. Times root 3 over 2. So now let's see. Denominator here, 2 times the square root. Denominator here, 2 times the square root. That's a common denominator, 2 times the square root. Okay? Numerator, I have x minus root 3. Yeah, that's the answer. Not that bad. Okay? Now, okay, next, verify the following. Okay. This that you have here is an identity. This is the, even and odd identities, right? So what it's telling you to do here is to verify, meaning to kind of like prove it. This is just like, proofs, but we're not going to do 2-column proofs, but we're going to verify. We're going to see, how is it that like the Greeks came up with this identity? Like, where did this come from? It didn't just like fall out of the sky into some person's lap one day, right? So where did this come from? Every single one of these has been derived from something else. So here we have cosine of negative theta. Basically what we're going to do is we're going to work just on the left side, and then eventually we're going to see that we're going to end up with the right side. Okay, so cosine of negative theta. How do you write negative anything? Well, one way of writing negative anything is 0 minus that number, right? So there. So instead of saying negative 3, can I just say 0 minus 3? That's the same thing, right? So now if I have cosine of something minus something, all of a sudden it's a sum and difference identity. So this is cosine, cosine, sine, sine. So we do cosine, cosine, okay, 0 and theta, plus sine, sine. Okay, what's cosine of 0? 1. Cosine of 0 is 1. So this is 1 times cosine. What's sine of 0? 0 times sine of theta. So what's 0 times anything? Nothing. That goes away, 0. So what do we have left? Cosine of theta. So that equals cosine of theta. So do you guys see how they came up with the identities? Right? Isn't that cool? You have to just, verify. Okay? Well, but then it won't be negative theta, right? The reason why we did 0 minus theta is so it gave us negative theta.
0 minus
Any other number, it'll be cosine of that number, that other number. Okay. So, what about this one? We're going to prove, this is another identity, right? Well, this is the negative of the identity, but we're going to prove it. Okay. So, cosine, cosine, plus sine, sine. So we're going to see if, when all is said and done, is this going to equal sine of theta? So let's see. What's cosine of pi over 2? 0. So this is 0. That means that whole thing goes away, right? And so we have 0 plus sine of theta times what sine of pi over 2? 1. And this is sine of theta. So that too checks out. Okay, so that's another thing. So some Greek guy was like, oh, I wonder what cosine of pi over 2 minus theta is. And then, you know, this is how they can figure that out. Okay? Yep.
Could you give us one where like does it work?
No, because then I can't say verify, because verify in itself means like show that it is true.
Well, yeah, like can you verify that's wrong?
No, that's just silly.
Just make it sure.
No. Yeah.
Could you like graph it and then move it over?
So that's showing by graphs, right? But verifying algebraically is a different skill. But yes, that would be like another way. Anything in math, in upper level math, can be done in 3 ways: numerically, analytically, and graphically. One way is to graph and to show that something is true. One way is to do algebra analytically and show that something is true. Another one is numerically, where you literally plug in like a billion different numbers and to show that it's approaching the value that you want.
Isn't that one kind of thing is graphing?
The numerical?
Yeah.
Yes and no. Okay. Now, okay. This is an equation that we need to solve. So now, take a look at this equation. This is the equation. Look at this. The first half is an expansion, sum and difference. The second half is another expansion, sum and difference. This is like 2 problems in one. Okay? So, let's start. I'm going to color code this one. Let's expand this. Cosine, cosine, sine, sine. So, cosine, cosine, minus sine, sine. Now there is a minus. Oh yes, sorry, thank you. Cosine, cosine, sine, sine. Now there is a minus. This is sine, cosine, cosine, sine. In parentheses though, sine, cosine, minus cosine, sine equals 0. Now when you're lucky, which I mean we will be most of the time, things will like simplify, cancel, combine. It's kind of cute actually, okay? So let's see what we can simplify. Cosine of pi, -1. This is why you really needed to know the unit circle. If you have to stop and draw the unit circle fresh every single time, it just slows you down, right? Like you just need to move on. Okay, what's sine of pi? 0. What's cosine of pi? -1. Sine of pi, 0. Okay, so now let's just see what we have. Let's just like clean this up. So cosine of x times -1, that's negative cosine of x, minus 0, correct? Minus, in parentheses, -1 minus 0 equals, oh no, what did I mess up? -1 times sine x minus 0 equals 0. Are you guys with me? So this is negative cosine minus 0 minus negative sine minus 0. So let's see what we have here. Negative cosine x plus sine x equal to 0. Now, this is not a sum and difference identity anymore. But now we have a situation. When you have a situation like this, you're like, wait, what can it be? What can it be? Then, you know what? You've never seen one like this, so we're just going to step back and think about this for a minute. Let's think about this for a minute. What if, for fun, we added cosine to both sides? Then it would be sine of x equal to cosine of x. Is that right? No. Now, hang on. Now let's think. For what values is sine and cosine the same? For pi over 4, because the sine is 1 over root 2 and the cosine is 1 over root 2. Now, many times when you have a problem like this, it will be like the ones we've been solving until now. You'll get like, cosine of x equal to a half, sine of x equal to root 3 over 2. Sometimes you get this, and I really want you to be able to reason out and say, oh my God, the point where cosine and sine are the same are at pi over 4, and where else?
The third quadrant.
Here. So here it's 1 over root 2, 1 over root 2, and then here it's negative 1 over root 2. So x is pi over 4, 5 pi over 4. Okay, yep.
Cosine x plus sine of x would be 3 pi over 4, so pi over 4.
Yeah, where it would be the negative. Okay, all right. Now, what we're going to do here, okay, is we're going to get used to a skill that you're going to use a lot in chapter 12 and then in calculus. So, here's what we have. Given that f of x is this function, so that's your f of x. We want to expand it for the difference quotient, this. We want to basically convert that into this. It's like, what do you call it? Like, like a, oh my God, transformation, okay? Almost. So remember how, so this is f of x equal to cosine x, right? So remember how when I would say, for example, okay, what's f of pi? What would you do? Cosine of pi, right? If I say f of a, what would it be? Cosine of a. Now, what we're going to do is we're going to build this. G of x is equal to f of x plus h minus f of x over h. So these are three different things. So f of pi would be this. So now f of x plus h would be what? Cosine of x plus h. So here I have f of x. If x gets switched to pi, x gets switched to pi. If x gets switched to x plus h, x gets switched to x plus h. Okay? Right. F of x is cosine x. F of x plus h is this. So if I were to tell you what's f of table, what would it be?
Cosine.
Cosine table. And now what is this? Cosine of a plus b. So let's expand it.
Are you saying f is always cosine or just?
No, in this problem. So cosine minus sine,
This is
sine. Huh?
we're trying to find the cosine of the table.
Oh, yeah. Yeah. Okay, so g of x is equal, okay, let's do this, then you'll have time. Shh. So look, this is f of x plus h. Okay? But that's only like a part of what I need to do. Now the recipe says that's just this, minus f of x, which is cosine of x, over h. And then we're just going to leave it like this. Why? Because in chapter 12, we're then going to do other stuff to it. But I have found that by the time we get to chapter 12, there is like so much to do that I don't want to spend time teaching students how to do this. So we're going to do this now. And then remember, everything we do is because of something else we're going to do at a later time. It may be in chapter 5, it may be in chapter 12, it may be in chapter 7, 8. Okay? All right, so that's that. Look at that. That would be your answer. So homework is from the book, okay? All right.